we want to find the centre of mass for the three masses here, which are shown lined up on the x-axis. In order to have the same linear effect, our mass must have the combined mass of the objects. In other words, it must have a mass of 14 kilograms. Let's call its coordinates x bar and 0. Clearly, the y-coordinate is 0, since this object must be on the x-axis. To get the position right, the turning effect for our centre of mass must be the same as the turning effect for the other objects. Let's take moments about the y-axis. In order to do this, let's collect information about the mass and position of each object involved. We have a 4 kilogram mass at -5, 0. We have a 3 kilogram mass at -1, 0. And we have a 7 kilogram mass at 9, 0. We want to replace these with a 14 kilogram mass at x bar, 0. We want to find the turning effect for each of our masses. Their distance from the pivot is given by the x-coordinate, and if we retain the sign, this also gives us the sense, either clockwise or anti-clockwise, of the rotation. We'll look at this in more detail a little later in this example. For this mass, we're going to give a moment of 4 times -5. Strictly speaking, of course, this should be weight times distance rather than mass times distance, but in order to change mass to weight, we multiply by g. Since we're going to do this throughout an equation, the g would just cancel back out. So we can use mass times x-coordinate. For the 3 kilogram mass then, we're going to have 3 times -1. For the 7 kilogram mass, we'll have 7 times 9. And for the combined mass that we want to replace it with, we have 14 times x bar. And our combined mass needs to have the same turning effect as the individual masses, therefore giving us this equation. Look at how preserving the sign on the coordinate helps us with the sense of the moment. 4 times -5 is -20. This is negative, and we can see here this produces an anti-clockwise moment, as does the 3 times -1. The 7 times 9, however, is on the other side of the pivot, and this is going to turn us clockwise. So the negative ones are turning us anti-clockwise, and the positive one is turning us clockwise in this question. Here we have -20, take 3, add 63, which comes to 40, is equal to 14x bar, and this tells us that x bar is 20 over 7. Therefore, we need to place our centre of mass, which is 14 kilograms, at the position 20 over 7, 0.